Welcome. This video describes a scientific concept called significant digits. And before we get going, the purpose of significant digits is it's a way we have of expressing a degree of certainty or reliability in scientific measurements. And before we get going, I have to dispel the normal usage of the word significant. Usually significant means important, and in a measurement, all digits are important. In science circles, the term significant with significant digits means certainty. It has to do with how certain or reliable measurements are. Okay, so we define significant digits as digits that are known with certainty, those that we can directly, verifiably observe, together with one estimated digit. So the estimated digit is also a significant digit. So if we were trying to read the length of this line, we can see clearly that it is past the 3.1 centimeter mark. So 3.1 something would be the reading of this measurement. So when making a measurement, you do three things. You record all digits that you can see. That's what we're certain of. So I can see that it's past the 3.1 line. Then my estimated digit is 3.15. So I want to estimate one past the markings. So the measurement would be 3.15 centimeters, and each one of these digits is significant. So there would be 1, 2, 3 significant digits. So if I'm measuring back to this illustration we used before, if I have a meter stick with no markings on it, and I have a stick here that I'm trying to measure the length of, I can see that it's about halfway, a little past halfway. So I have zero certainty on its length, but I can estimate that it's about 0.6 of a meter. So there would be one significant digit, the 0.6, one significant digit. If I have a meter ruler that has decimeters on it, I am certain that it is past the 0.6 mark, and I estimate that it's about 1/10 past the 0.6 mark. So 0.61 meters, so there would be 2 significant digits in this measurement. And then if I have a ruler that has centimeter markings on it, I can see clearly, and I can know with certainty that it is less than the 0.61, and I estimate that it's a little more than halfway, so 0.607. The 0.60 is certain, and the 7 is the estimation. So there's 1, 2, 3 significant digits. Now I have two questions for you. Which of these is a more correct way of expressing the length of the line for the measuring device used? And we can say that they all are correct for how the instrument is used. But which one is more accurate? That one we can say this is more accurate because we have a higher degree of certainty because the markings dictate that, and we estimate one past the markings. Now, a little bit of practice on reading calibrations. First of all, with a beaker. This will illustrate why we don't use beakers to measure volume of liquids, because they're just not very accurate. So what you do is you count the number, or you count the two labeled markings, and you subtract the difference between the labeled numbers. So you could either say 200 minus 150 or 50 minus 0. And then you divide that by the number of spaces, and there's 1 space, 2 space, so each space counts for 50 divided by 2, each space counts for 25 mils. So if you had, say, 10 drops added to that beaker, you wouldn't be able to see the line move up and down at all. So that's why we don't use beakers to measure volume. They're just not very well calibrated. So if we do want to measure volume, we would use something like a graduated cylinder. So if you look closely, before you can read the volume, you have to figure out what do the markings count for. Okay, so if we do the same things, subtract between the two labeled numbers. So 25 minus 23 is 2. So, and there's 10 spaces between them, so 2 divided by 10 is 0.2 milliliters per space. Okay. So if we read the bottom of the meniscus, which is what convention dictates, we can see that it's 0.2 0.2, 0.4, 0.6 above this line. So what does that line represent? Well, you can see the numbers are resting on the lines that they represent. So that's 25, that's 23, that's 21. So this would be 20. So it'd be 20.6 milliliters. And since it's right on the line, the estimated digit would be 20.60. So how many Sig Digs would be in this measurement? Well, let's hold off on that until we learn how do we count zeros. Okay. Now, what do the markings count for on this one? Here is the line we're trying to read. So if we subtract 50 minus 45, we get 5, and there's 5 spaces between, so each space counts for a milliliter. So see if you can read that volume of water in this graduated cylinder. Remember to estimate one digit. So this is 35, this is 40, so that would be 39, and since it's right on the line, we would say 39.0. Now, right off, you should be able to tell me how many Sig Digs are in this measurement. 1, 2 that we can see for sure, and then we're estimating, so there would be 1, 2, 3. Okay, next example. How would you record the length of this line with these two different rulers? Because there's a different degree of certainty with each ruler. So we can see clearly it's past this, less than this, about how far past, and that would be our estimation. So something like 12.5 centimeters. Okay, how many Sig Digs? 1, 2, 3. What about down here? Same stick, different measuring device. Here we can see that it is exactly on, oh, no, it's a little past the 0.5 line. I don't have my glasses on. So we would say 12.53. We know for sure that it's 12.5. It's a little past. We're estimating that it's 3/10 past. So how many Sig Digs are in this measurement? 1, 2, 3, 4. All right. Now, where is each letter compared to the 0 point? How far is it from 0 to A? Now, how many of you would have put just 1.5 instead of 1.50? And looking at it, I might even put 1.49. And either one of those would be correct, but just 1.5 wouldn't have the proper estimation on it. And for B, right on the 2.9 line. For C, right on the 4.2 line. D, right on the 5.3 line. E, right on the 6.1 line. Oops, I made a mistake, didn't I? It should be 6.6. This is 8.10, and that's right on the 12.0 line. So 12.00. Now, why do we care about this? Okay, so the reason for caring about Sig Digs is that we can only record a degree of certainty that we have with the measuring device that is being used. In addition, by looking at a measurement that is taken, we can infer what measuring device is being used. So how do we tell when a measurement is already taken, how do we tell how many digits are significant? Now, there are some formal rules, and every book has a slightly different wording of the formal rules. This, your textbook, they're found on these pages. I don't particularly care for, they're kind of wordy and kind of a little confusing. So I put the same rules into kind of teenager-friendly lingo. So, first of all, non-zero digits are what? Well, they are significant digits. So if there is a non-zero digit, you can assume that the person either had certainty of the reading or was estimating that digit. So non-zero digits are always significant. So in this measurement, 3.15 centimeters, there is 1, 2, 3 significant significant digits. So what about zeros? Well, zeros can be kind of confusing. So there's several rules that have to do with zeros. So tweener zeros are significant. And by tweener, I mean zeros that are in between two significant digits. So if I have a measurement of 1.01 grams, then that zero is by nature a significant digit, because that one is the estimation, so we know that that is a certain. We know that it is certainly past 1.0 grams, and it's a tenth of the way past that. So there would be 3 Sig Digs in that measurement. So any and all zeros that are in between two significant digits are significant. And then estimated digits are also significant. By definition, significant digits are known plus an estimation. So 10.0 degrees Celsius, that zero is the estimation. So if we try to conjure up what kind of thermometer was used to make that measurement, we can see that it's 10, so it has single degree markings on it, and the estimation is a tenth past that, or that it's exactly on the line rather. So it's exactly 10.0 degrees Celsius. So there would be 3 significant digits in that measurement. Scientific notation, the decimal factor zeros are significant. So if I have 3.07 times 10 to the 5th kilograms, this is the decimal factor. There's 1, 2, 3 significant digits in that factor. This is where we show significant digits. This factor just tells you how big or small the number is. And there'll be another tutorial that will go through scientific notation. But this is where you count Sig Digs. And any and all digits that are in this factor are significant by definition. In fact, that's why scientific notation was one of the reasons it was invented. Placeholder zeros are not significant. So what are placeholder zeros? What do they look like? Well, there are 2 types of placeholder zeros depending on where the decimal place is. For small numbers, the zeros that are in between the significant digits and the decimal place, those zeros are merely placeholders. So they are not significant. This zero is a estimated digit. So it is... Sorry for the interruption. So these 3 digits are significant. These 3 are placeholders. What about for large numbers? 147,000. What's the role of these zeros? Well, in the case where there is no decimal place, the implied decimal place is right here. So these 3 are placeholders. So they are not significant. They're important. They need to be there. They separate 147 from 147,000. You can't just drop them off. They're just not significant. They don't tell us about the reliability of the measurement. Okay, so that's it for zeros. I hope that makes sense. The last rule has to do with counted or defined numbers. And we say by convention that they have infinite number of Sig Digs. And that just means that we consider those numbers to be really reliable, and we don't really factor them into the significant digit considerations. So if you're counting the number of people in a room or the number of fingers on your hand, you don't count those as being significant digits. They have an infinite amount of reliability. And then defined numbers like how many centimeters are in a meter? Well, there's exactly 100, and we have infinite certainty in that. So we really don't factor counted or defined numbers into significant digits. I hope that's helpful. Thank you.